Welcome to the chapter on electrical resistance and power. Understanding these concepts is crucial for any electrical engineering student. This chapter covers the fundamental concepts and practical applications of resistors in electrical circuits. In this chapter, we will cover the series and parallel connections of resistors, voltage and current dividers, electrical power, and practical applications of resistors in a power supply unit. When resistors are connected end-to-end, they are said to be in series. The total or equivalent resistance of resistors in series is the sum of their individual resistances. The formula is given by R total equals R1 plus R2 plus R3 and so on up to Rn. Consider three resistors with values R1 equals 2 ohms, R2 equals 3 ohms, and R3 equals 5 ohms connected in series. The total resistance is R total equals 2 ohms plus 3 ohms plus 5 ohms, which equals 10 ohms. A voltage divider is a simple circuit that turns a large voltage into a smaller one using two series resistors. The output voltage is given by the formula V out equals V in times the ratio of R2 to the sum of R1 and R2. If Vin equals 12 volts, R1 equals 2 ohms, and R2 equals 4 ohms, the output voltage is V out equals 12 volts times the ratio of 4 ohms to the sum of 2 ohms and 4 ohms, which equals 8 volts. When resistors are connected across the same 2 points, they are in parallel. The total or equivalent resistance of resistors in parallel is given by the formula 1 over R. Total equals 1 over R1 plus 1 over R2 plus 1 over R3, and so on up to 1 over Rn. Consider three resistors with values R1 equals 2 ohms, R2 equals 3 ohms, and R3 equals 6 ohms connected in parallel. The total resistance is calculated as 1 over R total equals 1 over 2 ohms plus 1 over 3 ohms plus 1 over 6 ohms, which equals 1 ohm. Therefore, R total equals 1 ohm. For two resistors in parallel, the total resistance can be simplified to the formula R total equals the product of R1 and R2 divided by the sum of R1 and R2. If R1 equals 4 ohms and R2 equals 6 ohms, the total resistance is calculated as R total equals the product of 4 ohms and 6 ohms divided by the sum of 4 ohms and 6 ohms, which equals 2.4 ohms. A current divider is a circuit that distributes the input current among parallel branches. The current through a resistor in parallel is given by the formula II equals I total times the ratio of R total to Ri. For two resistors, R1 equals 2 ohms and R2 equals 3 ohms in parallel with a total current I total equals 5 amperes, the current through R1 is calculated as I1 equals 5 amperes times the ratio of 1 ohm to 2 ohms, which equals 2.5 amperes. Electrical power in a resistor is given by the formula P equals V times I. Using Ohm's law, power can also be expressed as P equals I squared times R, or P equals V squared divided by R. If a resistor with R equals 4 ohms has a current of I equals 3 amperes flowing through it, the power dissipated is calculated as P equals I squared times R, which equals 3 amperes squared times 4 ohms, resulting in 36 watts. In a power supply unit, resistors are used to regulate voltage levels. For instance, consider a power supply that needs to provide 5 volts from a 12-volt source using a voltage divider. Using resistors R1 equals 7 ohms and R2 equals 5 ohms, the output voltage is calculated as V out equals 12 volts times the ratio of 5 ohms to the sum of 7 ohms and 5 ohms, which equals 5 volts. This simple example demonstrates how resistors can be used to achieve desired voltage levels in practical circuits. By understanding these fundamental concepts and equations, students can analyze and design basic electrical circuits involving resistors and power calculations. Thank you for watching.